In this video, we are on pages 3 and 4 of your Supplementary Notes page for Lesson 7.4. And in this problem, we're going to be using the properties of rectangles, rhombuses, and squares to prove if a parallelogram is one of these types of shapes. So first, when we are proving that a parallelogram is a rhombus, a rectangle, or square, these are the three steps that we are going to take to figure out if it's a rectangle or a rhombus or a square. So if we have a parallelogram, to figure out if it's a rectangle, we're going to check to see if the lengths of the diagonals are the same. If they are, we know it has to be a rectangle. That goes with the property that the diagonals are congruent in a rectangle. Keep in mind that when we're finding lengths of diagonals, we're going to be using the distance formula. In order to prove a parallelogram is a rhombus, we are going to check to see if the diagonals are perpendicular. If they are, then the parallelogram is a rhombus. That goes along with the property that the diagonals are perpendicular for a rhombus. When this is on a graph and we're given some points, we're going to be using the slope formula to determine if the diagonals are perpendicular. And lastly, to know whether or not the parallelogram is a square, if you can prove that the parallelogram is a rectangle and a rhombus, so both of these are true, then you know it has to be a square. Okay. And so we're going to put these three steps into practice on the next page. Okay. Example 5, decide whether parallelogram ABCD with these vertices is a rectangle, a rhombus, or a square. Give all names that apply. Okay. So we have a graph here and we're trying to determine which of these three, if any, is this parallelogram. So first we're going to check to see, is this parallelogram a rectangle? So remember, we're going to determine if the diagonals are congruent using the distance formula. Okay. So here's our distance formula that we will be using, and we'll be plugging our points into this formula. Okay. So in this parallelogram, we're interested in the two diagonals. One of the diagonals is diagonal AC here in purple. So I'm going to be using points A and C and plugging those to the distance formula to find that length. Okay. So we're going to find the distance of AC using point A, which is at -2,6, and point C, which is at 4,0. Now, when I use the distance formula, I like to label my points x1, y1, x2, y2. And I'm going to go ahead and start to plug this in. So the distance, or the length of AC, is equal to x2 minus x1 is 4 minus -2 squared plus y2 minus y1 squared, 0 minus 6 squared. I'm going to do what's inside the parentheses first. 4 minus -2, that's the same as 4 plus 2, that is 6. And 0 minus 6 is -6. I'm going to square these numbers here. 6 squared is 36. -6 squared is 36. 36 plus 36 is 72. So you don't have to take the square root of 72. You could leave it like this. But when you take the square root of 72, you get approximately 8.48. So now we need to check the length of the other diagonal, and we're wondering if it's equal in length to AC. So now we're going to use B, which is at 6, 8, and D, which is at -4, -2. And we're going to do the same thing. We're going to label these x1, y1, x2, y2, and we're going to plug them into the distance formula. So the length of BD, x2 minus x1 squared would be -4 minus 6 squared. Y2 minus y1 squared is 2 minus 8 squared. -4 minus 6 is -10. 2 minus 8 is -6. When I square these two numbers, I get 100 plus 36. Oh, I noticed a little mistake I made. Point D is at -4, -2. So this is a -2 here. -2 minus 8 is -10. Sorry for that mistake. So I have 100 plus 100. So I end up with the square root of 200. I can tell that is not equal to the square root of 72. When you take the square root of 200, you get about 14.14. So these diagonals are not congruent. So we would say this parallelogram is not a rectangle because the diagonals are not congruent. And looking at that shape, you probably would have guessed that doesn't look like a rectangle anyway, but we just need to make sure we prove that mathematically, which we did. Now we want to check to see if this is a rhombus. So remember, to check to see if it's a rhombus, we want to check if the diagonals are perpendicular using the slope formula. So we're still going to use our two diagonals. I'm still going to use those points A and C, and then B and D, but this time I'm going to plug it into the slope formula. Remember, the slope formula is m equals y2 minus y1 over x2 minus x1. That will be given to you. So let's use, I'm just going to use these 2 points from up above, okay, using the same labels. So the slope of AC y2 is 0, minus y1 is 6, x2 is 4, minus x1 is -2. Okay. So I'm left with -6 on the top and +6 in the bottom. So I have a slope of the slope of diagonal AC is -1. I now need to find the slope of BD. I'm going to use these points here. I'm going to keep the labels. So the slope y2 minus y1, -2 minus 8. Over x2 minus x1, -4 minus 6. When I do the subtraction, -2 minus 8 is -10, and -4 minus 6 is -10. -10 divided by -10 is +1. So remember, to determine if lines are perpendicular, the slopes, remember, those need to be what we call opposite reciprocals. So remember, opposite means one is positive and one is negative, and reciprocals means they are flips of each other. So if you have a whole number, you can always turn it into a fraction by putting a 1 in the bottom. So we want to know, is -1 and +1, are those opposite reciprocals? Well, this slope is negative, this is positive, so they are opposite. And if I flip them, 1 over 1, if I flip 1 over 1, I get 1 over 1, right? So they are also reciprocals. So because these slopes are opposite reciprocals, the diagonals are perpendicular. Okay, so they are perpendicular. So this is a rhombus because the diagonals are perpendicular. So lastly, we want to know, is this then a square? Remember, to be a square, it has to be a rhombus and a rectangle. So we have already established that it's not a rectangle. So guess what? That means it cannot be a square. So this is not a square because it is not a rectangle.